So this is the perfect programming process, and it is supposed to be perfect. It shouldn't fail, but the last time I tried it, I failed miserably. However, I'm going to try again, and this time I'm going to trust that the process is actually perfect and follow it to the letter. I'm especially going to put in a lot more effort in these early steps here and do them as thoroughly as they should be done. Once again, I'm going to create a simple tic-tac-toe game that can be played in the browser, a game without any intelligence on the computer part, just as simple as can be. So on to step 1, understand the problem. And in my original video, I said the following. If you're recreating a card or board game, play that game with a friend if possible. So I've been to my local toy store and bought an actual tic-tac-toe game. So let's play a few rounds. As I don't have a friend with me right now to play the game with, I'm going to take on roles as both players. The human will be playing O's and the computer will be X's. So first, O selects a field. And then X selects a random one, like this. And then O selects a new field. X selects a random one again. Okay, that was already taken, so it can't select a completely random one, but has to select a random one that was available, like this one. Now O selects an available field again, like this, and X selects once again a random one there, and O selects its final one and has 3 in a row and wins the game. But playing just one game isn't enough. I need to at least try a couple of times to understand if there can be different outcomes. So let's play one more time. So the human starts with selecting this one. Then the computer takes that one and the human goes for this one. The computer then randomly selects that one in the corner and the human immediately takes that one there. Then the computer goes for this one and the human takes the one in the corner. Then the computer takes that one and there's only one left for the human to take. And there are no more fields available. The game is over. It ended in a tie. No one won. I actually think that was what broke my program the last time. It went to an infinite loop looking for available fields when there were none. So this is very good to know. I guess I know enough now. Of course, I haven't played through every single combination that could win the game. So I will have to do that analysis when understanding the solution. And that is actually the next step. Understand the solution. I will start by writing down what I just learned in my trusty notebook here. That was the old solution. Let's try and forget that ever existed and start a new one. So, tic-tac-toe, we2. In the game, the first thing that happens is that the user selects a field. And this is the step that happens inside the user's head. The user decides to select a field and clicks on it or something, and then in our program we mark selected field with an O. And then of course the computer selects a field, but before that we need to check if there is a winner. The first 2 times the user selects the field, it won't win, of course, but the third time this happens, we need to check winner. And if there is a winner, that means that the user has won, and we end the game with user 1. Otherwise, we continue and then we let the computer select a field. But it shouldn't just select any field, it should select a random available field, since we don't want it to select the same one that the user just selected. And then we mark that selected field with an X. But of course it could happen that there weren't any available fields left. No available fields. And this will also end the game, but in a tie. Finally, we need to check for a winner again. Because now the computer might have won. And we end the game for the 3rd time with a computer one. And if not, we just continue and go all the way back and run through it. And let me just draw some arrows to be nice. Actually, I wonder, when the computer has to select a random field, we need to check if there are no fields available. And I wonder if the same could happen when the player has to select a field. So let me just try that. First, the user selects a field, the first available field. And then the computer selects the next one, then the user, and the computer, and the user, and the computer, the user, the computer, and finally the user selects the last available field. No more fields on the board and no more blocks in this physical game. And I wonder, will it always be like this, or could it be the computer that selects the last available? So let me try again, but this time without placing them. Let's see. We have the user and the computer. These are our 2 players. They always placed in a pair, first one, then the other. So this here would be, no, not like that, like this and like this. So 1st round, 2nd round, 3rd round, 4th round, and 5th round is the user setting the last piece. These are 2, 4, 6, 8, 9. Because we have an even number of players and an uneven number of fields, then the first one to position a piece is also the last one. So yes, there will always be an available field for the player. I should say, no, we don't need to check for available fields when it is the player's turn. It is always the computer that runs out of fields because it starts second. Good. And yes, this would technically be part of understanding the problem, but it's perfectly okay to do it at this stage in the process. After all, you can't be expected to know or predict everything from the beginning. The process is supposed to be iterative, and you'll often have to go back and adjust or rework some of an earlier step, like adjusting the plan when you learn something new when filling in a blank, or indeed changing what you thought you knew when a part turns out to be much more complicated than anticipated. It might seem a bit silly, this little dance of taking 1 step forward and 2 steps back, but it is still better than not moving at all because you're afraid you have missed something. Anyways, I think I have understood the solution fully now, except these parts with the check winner, I feel like I should understand them better. I could, of course, start programming and then just fake it and revisit it later. But I'm curious right now and also a bit scared of starting to program without fully understanding the solution. Because as I remember here, I have several different ways I can win the game. Like I could have a row, like this, and several different rows. I could also have columns, and I could have diagonals. So to get a full overview over everything, I've got this paper boards here where I could play the game on paper, but I'm not going to play it. I'm just going to use it to mark the winning situations. So I could have, for instance, if I have the first row there, that would be a winner. I could also have the second row. That would also be a winner. And I could have the third row. So these are the different rows. I could also have the first column. This would be a winner. A second column. Or the third column. And indeed, I could have the diagonals. So I could either have this one through diagonally here. I could have the other one diagonally there. And, well, yeah, that actually seems to be it. So only 8 combinations. Well, that wasn't that complicated. But then again, how can I put these combinations into a program? I mean, I can't just put these pieces of paper in the diagram here. I need some other way of expressing this or these winning combinations. Although I am keen on using pen and paper and other real-world objects, sometimes it also helps to simply try and explain it to someone just by using your voice. So pretend that you have to explain it over the phone. No photos, no pictures, no video chat, only voice. How could you explain to them what makes a winning combination, especially if they aren't bright enough to understand 3 in a row? I could name the fields individually depending on where they were, so that this would be the top left and this would be the bottom left and the top right and the bottom right and the middle left and the top middle and the middle and the middle bottom middle or middle. Oh, okay, I'm already getting confused. So while that would work, I'm confusing myself, so I need another naming system. I could give them name, like just name this one Alice, and Bob, and Charlie, and make up names for the rest of them. Dan, and Eric, Fred. But while these names are easy to remember, they're not that logically connected to the fields. Like, I wouldn't say Bob, oh yeah, that's this one. Bob, yeah, okay, I remember he's always there. So I'm going to go even more simple than that and just number them. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then a winning combination would be like this one, 1, 2, and 3, or 1, 4, and 7, or 3, 5, and 7. This seems like something a computer would like. Let me write them down. A winning combination, winners, could be, and this 1 and 2 and 3, or it could be 4 and 5 and 6, or it could be 7 and 8 and 9. These would be the rows. or it could be the columns here, 1 and 4 and 7. I'm just going to write or between them, or 2 and 5 and 8, or 3 and 6 and 9. These will be the columns. Or it could be the diagonals, 1 and 5 and 9. Or it could be 3 and 5 and 7, the diagonals. So these would be all 8 winning combinations. This seems like something a computer would like. Maybe it could be simplified somehow, but for now I just want to be able to understand how a winner is determined. Okay, now I think I have an exhaustive understanding of the solution. It certainly was exhausting. Next step is to make a plan. So let's identify parts in the solution. The first thing is the user selects a field and the field is marked with a node. That's 2 different parts, because this one here, that's something done by the user, whereas this one is something done by the computer or the program. And checking the winner here, this one is, just writing an asterisk, that is this big part down here. That would go into that, and that's the same as this one. They are the same. This one checks for X's and this one checks for O's. Maybe I should write that. Check winner O's, check winner X's. So that would be, let me just note here, they are the same, identical, but almost identical. Yeah. Letting the computer select a random available field and marking that would also be too different. Even though it's the computer that does both of them, something happens in between. I need to know if there are available fields left. And I think this mark the selected field would be very similar to this part, but the computer selecting would be very different from that part. So that's 2 different parts here, and marking it. And maybe I could just note here that this is very similar to that one. And then the end game, each end game would just stop the game, note that the user has won, stop the game, note that there's a tie, stop the game, and note that the computer has won. So I think it's the same part. I think this can be one part that just writes 3 different things. So my end game part here is a single one. I'm not entirely sure it can be programmed that way, but I certainly don't see a difference between them. That was the plan. Now for the next step, know what you know. And of course, as a somewhat experienced programmer, I can't help but thinking about programming even when working on understanding the problem and the solution outside of the computer. Also, the last time I did the same project, I learned a lot, especially about how not to do, but I'm going to clear my mind and do a fresh take on the plan and pretend that I'm a novice in programming who doesn't know much beyond selecting and manipulating elements on the screen, making the program react to the user's selection, using variables, if statements, for loops, and the most basic knowledge of arrays and functions. So as this person who hasn't done a tic-tac-toe game before, I will now mark what I know and what I don't know. I know how to select a field. I'm absolutely certain I have written something like that before. And I also know how to mark that field with an O. And I'm fairly certain it will be the same here, but might not, there might be a difference. But I'm just, to make sure, I'm just noting it down a bit. Checking the winner is, well, I have this logic here, and I think it's just a question of asking if that field and that field and that field is selected. But I'm not sure. I haven't written something like that before, so I'll mark it down like this. Making the computer select a random field, I do not know how to do that. I have some thoughts, but I'm absolutely not sure. This is something that I will need to learn. Making the end game, writing a message, that should be fairly simple. I think I know how to do that, but there might be some complications with writing different messages. So I will mark that as an I'm not sure. And that goes for all three of them, because I think it's just one part. So that should be this one would be the same as that one. Maybe mark this asterisk here. Because when I have this, I can just copy it to here and change O's to X's. But I won't be able to do that without having done this before. Now I'm really ready. I can feel the program forming inside my mind. But I'll try my best to put it aside and follow the process and the plan. And maybe I could have played through my solution here, pretend to play the game from this drawing rather than the rules as I know them. This would certainly verify that my plan is correct, but I feel that I have kind of done that multiple times when working through it here, imagining the game in my mind for every change I made. And explaining it to you certainly helped a lot, so thanks for that. But anyways, if I should get stuck in my programming, I will know that I can go back and re-examine the solution and maybe play it rather than try to code my way out. Anyways, it's time to get on with the next step, begin with the end, where you finally get to use the computer and build the end result. I actually think that I did this kind of right the last time, so I'm going to do pretty much the same thing once again. But as usual, I'll pretend that I haven't done the project before and just start from scratch. So I'll have my index HTML and my style.css in my HTML. Let's create it here. I will have my title, TicTacToe, and why not, just for the heck of it, done right. And let me give myself a headline, TicTacToe, done right. In the game, I will have a board, and that board will have 9 fields, each with a button like this, and 1, 2, 3, 4, 5, 6, 7, 8, 9. They will be fields. You know what? I actually think I should give them the class of field. And, you know, now that I think of it, I'm going to name them with field. And then, of course, not the same name. Field 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I had 10. And that was good that I named them, so I discovered that. So let's put some symbols inside some of the buttons. So say we have an X here and an O here, just to check if something will be displayed. Another X, another O, and another O. Let's see how that looks. Well, that looks absolutely awful. Of course, I don't have any CSS, so let me get started. I always do this. Body background color red. To see, it does not work because I always forget my CSS. I don't know why I always forget it and then always have to check. There we go. Now it works. And I can turn off this color again. So these buttons, they should be in a grid. The board display grid with some 3 columns. So grid template columns. Let's just 4 M's, I think, seems like a good size. Yeah, that works. And then each field inside the board. And I have my class here. They should be square. So let's give it an aspect ratio of 1:1. I like that. Let's make the font a bit larger here. Font size, I don't know, 250%. That looks fine. It could be a bit fatter. So let's give it a font weight of bold, not fatter, bolder. Yeah, I don't know. It looks. Oh wait, my font should really be font family some Arial. I think this is the same actually. Okay. Let me just give myself a bit more space between everything just to make it look nice. 2 pixels gap. Yeah. Oh, and I also need some way of writing a message for who has won or lost. I will do that here in my H2. The game is still on. No winner yet. Excellent. I like this. This is nice and simple, and I'm ready to write some code. That went well, as expected of course, and I even managed to add the names of the fields, these 1, 2, 3 here. I don't use them for anything yet, and they aren't being displayed on the screen, but I do like the fact that I can refer to them in the same way that I refer to them in my solution here. It might turn out to be useful, or it might not matter at all, but it's always preferable to use names from the problem and solution rather than make up new ones in the program. No matter, I'm ready for the next step, to pretend that I know it all. And as mentioned, I will act as a novice programmer and not design a structure using functions or anything fancy like that, but simply write comments for each part of the plan. To write the comments for the structure, I need somewhere to write them, so I'll create my script.js and remember to include it here in the HTML. So now I should be ready. And the first thing is the user selects a field. And then that selected field is marked with an O. And then we check winner. Check if O is a winner. For O. I will skip the details of the check winner right now. So just say if user is winner, then we end game user won. And if not, then the computer selects a field. Or it selects a random available field, to be specific. And then we need to make sure if no field is available, then once again we end the game with a tie. Otherwise we continue and mark the selected field with an X. And again, we check for winner. For X. And if there is a winner, we end the game. Computer won. And if nothing else, then we repeat. So let me write the details for the check winners here. For O's, there are 3 different kinds of winning. There were the rows, the columns, and the diagonals. So rows, let me just get rows would be 1 and 2 and 3, or 4 and 5 and 6, or 7 and 8 and 8 and 9, or it could be columns 1 and 4 and 7, or 2 and 5 and 8, or 3 and 5 and 7, or it could be diagonals 1 and 5 and 9, or 3 and 5 and 7. And of course that would be for O, and then that would be the exact same thing down here for X. Oh, I forgot to write, I just ended the game when I check for winner. I only end the game if computer is a winner. If computer is winner, we end the game. So that was easy. It always is. After all, I just pretend to know it all. But I do feel confident that this structure will hold. Maybe there'll be some issues with the end game part. Maybe it's not going to be one part after all. But I think I can manage that when I get to it. And I'm eager to get to the actual programming in the next step, filling the blanks. I will start with letting the user select the field. That is one thing that I absolutely know how to do, and it would also give me something visual, especially combined with the next thing, marking that selected field. Letting the user select the field should be simple enough, because these fields are buttons, so I can just register a click on a button. So if I select my first button in field 1, add an event listener on that. Once it's been clicked, I will call my function selected field, click field. Let's call it that. And create that function here, click field. And that should contain everything, I guess. So let me just write a console log here. Clicked field 1. And of course I need to inspect that it's actually happening. Clicking field 1. Yes, click field 1. So that works. And then I just need to mark it with an O. And that should be fairly simple by saying this text content should now be set to an O. So when the user clicks the field, it becomes an O. Excellent. And now I just need to do that for all 9 fields. So I'll copy this 8 or 9 times. Field 1, field 2, 3, 4, 5, 6, 7, 8. This time I only got 8 and 9. Then I can click. Yeah, okay, it's a bit hard to see, so let me just get rid of these temporary displays here. Clear all of them. And then I can click any field and mark it. Excellent. Then I can do the same for the computer. And here, let it select a random field, const random field. And of course, I would have to fake that, and let me just select the middle one. That would be 1, 2, 3, 4, 5. So document querySelector field 5, and mark that selected field with an X. Random field text content is an X. So when I click a field, the computer selects the middle one, and when I click another one, it still selects the same one, even though it should really select a new one. Now I've completed the parts that I know how to do and faked one of them and kind of ignored another. So I'll have to choose what to do next. Should I build the check winner or unfake the random selection? I could argue for the check winner, since I am actually able to win the game by either selecting the first or last row or first or last column. But I can't win diagonally with the current fake. And of course the computer can't win at all, and neither can we end in a tie. But I do think it would be more fun to get the random selection to work first, than just ignoring winners completely. It's also a part that I absolutely do not know how to write, so I will have to do some research and experiment a bit first. I am, however, not stuck in my programming. As long as I know that I'm switching from working on writing code to working on researching how to write it, I will be okay. Because I can always stop and go back, refake the part, and throw away my experiments. So let me research. First, let me see. I do know how to get a random number between 1 and 9. So const random number. It's mat floor, mat random, multiplied by 9, add 1. That should give me a, let me just make sure, console log, a random number. So every time I click, it says a random number 4, 2, 2, 4, 7, 5, 6, 4. Yeah, that looks random enough. Will I ever get a 9? Yes, 9 and 1. So I could just replace this 5 with my random number. So like this. And then it would select randomly number 4. And what? Oh, yes, of course. I selected number 2, and then it randomly selected number 2. Of course, it does not respect that they are already selected. Like, yeah, here it selects number 8 twice. So I need to select a random available field. So I should, once I mark a field, I should mark it as marked. I should mark it as unavailable. So I think I'll do here, say this class list add unavailable, and of course it should do the same when the computer selects one. So when I look here at the board, I can see now field 1 is unavailable, and so is field 6 that the computer has selected, and so is field 5. But of course, oh yeah, it doesn't really care. I need to make it select only an available field, but I only know the fields that are unavailable. So I should write code that selects a not unavailable field. You know what? I think I'm programming myself into a new corner here. I should not mark the field as unavailable. They should all be available. And then once I select them, they are no longer available. So let me here add a class to each, oops, that was the wrong button. Add a class to each one of available like this. And then rather than adding a class of unavailable, I'm going to remove the available class, both here and here. And if I take a look, they are all available. And then when I select one, that is no longer available. And then I should be able to get a list of all the available fields. If I'm running out of space here, let me give a bit more space. So field 5 is no longer available and field 1 is no longer available. And if I click there, that is no longer available as well. And then I think I can get a list of all the available fields. If I say document query select all the fields that has the class available. Here I get a list of field 3, 4, 7, 8, and 9. So these are the available fields. And then rather than just select a random number from all the fields, I should select a random one of these. And I think if I can just say, okay, I want the second one, the field 4, then I should be able to, I still have this, let me just get a list. Fields, how do I do this? Fields is this one, that's the available fields, and then I can get my fields. The second one should be number 4, it's number 7. Ah yes, of course, it starts from 0. This is the 0th one. Number 0, number 1, number 2, 3, 4, and there's no number 5. So I should select a random one from this list. Honestly, I'm not sure if this was the process, a lucky guess, or my experience kicking in. I did find in my solution that I had to select a random available field, but I'm not sure that I would have thought of this selecting the available fields and then choosing a random one of those if I hadn't learned that random numbers should only be used when any outcome is acceptable, like throwing a dice, whereas one should always select a random item in a list if only some outcomes are acceptable, like drawing a card or picking a field. But never mind, it doesn't really matter because what I wanted was to select a random available field. If I coded something that didn't do that, that just selected a random field that wasn't available, then the code wouldn't work as expected, and I could try again, but that wouldn't be solving the problem. That would just be randomly trying until it worked. So if and when you get in this situation, make sure that you don't code something that can give you the wrong result. If you do, then ask for help, search the web, ask a friend or your favorite AI. You want your code to do as you planned. You don't ever want to have to write more code to check your other code and force it to try again. Unless, of course, the solution said that that is the way it should be done. Anyways, let me get back to the code. So the available fields, that would be my document query selector here. All the fields that are available. And then I select a random number, not to 9, but to the length of the available fields list. And then not +1 because I started from 0, I just found out that. And then of course the random field shouldn't be selected by the field number. That's a bit confusing now. I have my random number, that is my number in this list of available fields and not the name. Maybe I should have really not used numbers for names. Never mind. So the available fields, number, random number. And that should give me, I don't need to log it anymore, I think. And that should make, I can select one and the computer selects another. And I select this one and select that another one. And of course there's no winning condition yet, because otherwise I would have won and the computer would win. And now it fails. Now I'm done researching and experimenting. The select random available field works perfectly and only fails when there are no available fields to select. But I've already planned for this. This should end the game with the message of a tie. So I'm back to filling in blanks and can finish the next part of the game. If there's no available field, if the random field here is not defined, that means no field is available. If no random field, then we end the game in a tie. Console log end game in a tie. Yeah, and let's just write it here in my H2. Document query selector H2. Text contents again. Game over. It's a tie. And if not, then we continue with the rest of the program. So I can select one there, there, and now I just have to try and not win. And there's no, yeah, there's actually a winner. I did win, but there's a tie. And oh, I shouldn't really be able to click. And that's cheating. No, once just like the computer shouldn't be able to select an available and not available field, I shouldn't either. That should be easy. Just like removing the available, I'll just remove the event listener. So, like, I'll take my field here, and rather than add the event listener, I will remove it. And do the same here with the random field. And remove event listener. That should also prevent me from clicking. So I can click there. And now, yes, now I can't cheat. And we end in a tie, even though there is a winner. And so it's time to write the check winner code. And now that I think of it, it was probably a good idea to do the random selection here first, because I wouldn't have been able to end in a tie and take all the available fields if I always won the game after just 3 rounds. Of course, if I had implemented the check winner functionality first and wouldn't be able to end in a tie, I could just have refaked that check winner so that there was no other way of ending the game than in a tie. And you'll often find yourself in this kind of situation, especially when dealing with randomness. So be prepared to fake, unfake, and refake parts of the program to make it behave exactly as you want to when testing. Anyways, let me look into the check winner. When checking for a winner, I want to see if some of the fields have the same mark, like if field 1 and field 2 and field 3 are all marked with an O, then we have a winner on that row, just like here. And the way that I mark them is by setting the text content. So I could, for instance, see here, select my field 1 and then set the text content to an X, then it's an X. And I could do otherwise and set it to an O, and that is an O. That's how I mark them. And I could do the exact same thing when wanting to ask, not setting it equal to, but just ask, what is it? And I get an O. So I could basically just write a huge if statement, ask if document query selector field 1 text content is equal to a no, and document query selector field 2 text content is equal to a no, and so on and so on. It's a bit much to write, so I'll make some quick constants for everything, like const f1 would be document query selector field 1 text content. And then I would have 2, 3, 4, 5, 6, 7, 8, and 9. 2, 3, 4, 5, 6, 7, 8, and 9 for each field here. 2, 3, 4, 5, 6, 7, 9. And then I would check the rows, say if F1 is equal to an O and F2 is equal to an O and F3 is equal to an O. Then we have a winner on the first row. So let me just check this. First console log, winner, first row. So if I have this one, and this one, and this one, there's a winner on the first row. And of course the game can still continue because I just console logged that there is a winner. So I can do the same for the other rows. I could say, okay, if I have this condition, or I have the next one, that would be F4, F5, and F6, and F4 is equal to O, and F5 equal to O, and F6 is equal to O. Then it would say that if either of the first two rows, first or second row. So let me just try that. Can I win? Yes, I win in the second row. Let me try again. Can I also win? I should really have... There, I can also win in the first row. So let me just do that one more time. For the last row, 7, 8, 9. 7, 8, 9. And that would give me... let me just see if I can actually... A winner. Now it's just a winner row. So now I can win in a row, and I'll do the exact same thing for the column. And I actually think that I'll just copy and say for number 1, number 4, and 7. It's 1, 4, and 7. And then let's take 2, 5, and 8. 2, 5, and 8. And of course 3, 5, and 7. 3, 5, and 7. That should be the columns. 1, 2, 3, 4, 5, 6, 7, 8, 9. That looks like a... Oh, I've copied the diagonal into the column. That should be 3, 6, and 9. Oh, that was good that I discovered that. So 3, 6, and 9. And the same down here. 3, 6, and 9. Okay, now I better test it, because winner, row, or column. Can I just... 1, 4, 7, 2, 5, 8, 3, 6, 9. Let me just try it out. Can I win? I can win in a row like that. I can win the first column. can win the second column. I can win the third column. Good, everything works. I can win the game. And then of course, last the diagonals. So we have 2 of those. And that should be 1, 5, and 9, 3, 5, and 7. So 1, 5, and 9, or 3, 5, and 7. Then we have a winner. And I'll do the same as before here. Game over. You won. And if not, then we continue with the rest of the game. Let's see, can I? Yes, I won. Oh, and I can continue playing and win again. I should really remove... Oh, how do I do that? I'm just going to remove all the event listeners. It doesn't seem like... It's probably not the most efficient way of doing that. It is certainly not the most efficient way. But I'm just going to remove every single one. So if I win, game over, you won, and I can't click anymore, I can win the game. Perfect. To be fair, I should also allow the computer to win. I'll just copy everything here, because that worked perfectly for O's. So I'm copying even more. I'm copying everything right there. And then I will paste it in here. So all the text content, and then I just need to change all these O's to X's. And I think I can do it like this. Mark them all. And write X's, except the first one. And then computer 1. Let me see if the computer can win. It can win diagonally, or now it's really stupid computer. So it can win, like it can win in that column. So I just have to try, and now I win because it does not want to. Oh, come on, computer, you can do this. It can win that row or that column. So yes, come on. Yes, the computer can win in a column, and I can't click anymore. The program works exactly as planned. And what a pleasant experience it was to write. I didn't get stuck once. I did have to research and experiment with that one thing that I knew I didn't know how to code. But that was as expected. And maybe I got lucky and remembered something about drawing random cards, but it definitely helped that I knew what the solution required, and I simplified my code to use the same descriptions and kept from doing some double negatives like all not unavailable or something like that. So the process works. I and you just need to respect it and remember that there's more to it than coding. I think that if you look at the timestamps of this video, then the first half of the process takes at least as long as, if not longer than, the second half. It is extremely important to fully understand the problem and the solution before throwing oneself into writing code. And by actually playing the game And pretending to be a bit more naive than any ordinary person, I found some of the hidden rules that aren't usually stated, like that you can't put pieces on top of one another. This helped me a lot in describing how the computer should select a field. And by analyzing the solution fully, I found that I needed some way of referring to each field so that I could check for a winner the simplest possible way. Once again, something that helped me a lot in programming. And those were the exact parts that broke me in my first attempt, where I forgot all about what the actual problem was and tried to invent code on the fly to solve what I thought was the problem, selecting a random field. Tried and failed, I might add. Granted, while my code works this time, it isn't the most elegant code. It is in fact quite repetitious and have large parts that are almost pure copy-paste. The check winner for one, and my idea of having a single endgame part didn't quite happen. I'm sure a lot of you have several suggestions on how to improve the code, and I feel you. I can almost hear you. But that should be the next step. The first step was to get something working from the plan. Then it can always be improved later. I also kept it as simple as possible to show that you can get something to work without being that good at coding, but by understanding the problem and the solution. I hope that this demonstration has, well, demonstrated that the perfect programming process lives up to its name, that it is indeed a perfect process. More than that, I hope that you now will try it on your own projects and start as small as possible. Maybe not with a tic-tac-toe game, but what about something close, like Hangman or Checkers or Color, Ludo, or another simple game that relies a lot on chance, so I don't have to include any intelligence for the computer. And when you do, remember to code things a bit simpler, a bit uglier than you would normally do. Don't take shortcuts in your code if you haven't done it in your planning. You can always go back and improve on the working game. It is, after all, much easier to improve on something that works than something that doesn't. In future videos, I will revisit the tic-tac-toe game and demonstrate subjects like using functions for separation of concerns, generalization, better structure, and model view controller patterns. But for now, I will leave you to try your own projects. Enjoy Programming 2.0.